So today basically we're going to learn the significance of the boundary condition. Means we'll try to understand why the boundary conditions are required and why should we study the boundary conditions. Okay. So to understand the boundary condition, we are going to consider a very simple case of mobile communication. As So we are considering a very simple case to understand why should we study the boundary condition and why it is required to know. So we are considering that suppose this is a small box, or we can assume that this is basically a maybe your bedroom, okay, which is maybe you are sitting inside this room, and this gray color parts, these gray color parts are not these are the what I can say that the wall of the room, okay, the gray color, this gray color we are basically considering the wall, okay. So these gray color parts are nothing but your wall, okay. So this is basically made of brick, okay. So now what we are going to consider that maybe you are sitting inside the room, okay. So you are sitting inside means you are basically carrying a mobile phone, so you are simply considering a mobile communication means a phenomena. So where you are sitting inside this means room, you are carrying a mobile phone, okay. It's consider that this is basically your mobile phone, okay. So and this is nothing but the tower, which is basically communicating with this mobile, okay. You are communicating means your tower is sending some sort of electromagnetic waves, okay. It is sending electromagnetic waves, as well as your mobile is sending the electromagnetic waves. Now we are considering only one case, that the means the signal you are receiving from the tower, okay. So from this tower, okay, mobile tower, okay. So you are basically receiving some sort of electromagnetic waves, so it is coming to your mobile phone, okay. Now when it is coming to your mobile phone, what is basically happening, the tower is basically radiating the electric field and the magnetic field. We call it the electric field intensity and magnetic field intensity, right? So these are basically time varying in nature when it is released by the tower. So it is basically coming to your mobile phone in the form of electric and magnetic field intensity. It is time varying quantity, right? Okay. And whenever it will come to the mobile means it is basically coming from it is traveling a different medium, right? Okay. So when it will come to your mobile, first it will be, when it will be released from the tower, it will propagate in air medium, right? So it will first propagate in air, okay. And when it will come near to your house means here when it will encounter this wall, right? Okay. So when it is going to encounter this particular wall, then what will happen, it will penetrate inside the wall and then it will reach to the mobile phone, right? Okay. So it has to penetrate inside this electromagnetic waves which is coming, so it has to penetrate inside this particular wall, then only it can reach to the mobile. So it was coming initially from the medium which is air, okay. It has a dielectric constant, suppose epsilon r1 we are considering. For air, the epsilon r1, this equals to 1, okay. And when it will come to the means when it will penetrate the wall, then it will means face a different dielectric medium, because this wall must is made of some different material. So here the dielectric constant will be different, so this will be suppose epsilon r2, okay. And this value will be quite high, okay. It must be greater than epsilon r1, right? Okay. So your electromagnetic wave when it will coming from air to the wall, and now at the interface means at the boundary, okay, some sort of changes will occur, means whatever the electric and magnetic fields are there in air medium, when it will penetrate the wall, inside the wall this electric and magnetic field, okay, this electric and magnetic field, say it will be changed, okay. So this electric and magnetic field will be changed. Suppose here we are considering E1 and this one is H1. So here your electric field inside the wall, it will be changed to E2 and this will be changed to H2. And where from it is going to start, it is this changes is going to start exactly at the interface or at the boundary of two dielectric medium, right? Okay, so here I am getting two dielectric medium, right? One is air and another is brick, and this is the interface or this is the boundary. So here a condition is going to apply, a certain boundary condition is going to apply, which will tell you that, or which will give you the information about these changes, that how this electric field, okay, E1 will change to E2, and what will be the equation and how will calculate the values. Okay, similarly how the magnetic field is going to change to H2. Okay, how you are going to calculate, or how you are going to find out the value of H2 inside this brick or inside the wall, right? And this will be understand by the boundary condition. So here what kind of boundary condition we are going to get? So it is initially the electric and magnetic field is traveling through air, okay, then it is coming to the wall is also made of dielectric. So this is basically a dielectric to dielectric, means air to wall, both are dielectric. So here a dielectric to dielectric boundary condition is going to apply. So we will get, so here I will get the dielectric, okay, trick to dielectric, right? Dielectric to dielectric boundary. Now again when it will leave the wall and again it will reach to the mobile, means again it is moving from dielectric to dielectric boundary. So here this is wall and this is basically your air, okay, both are dielectric but two different dielectric constant. So here also the electric and magnetic field, when it will come to the air, it will be again changed to some different value. So it will be E3 and again this magnetic field may be H3, okay. So from wall to the air, okay, when it will move, it is moving from one dielectric medium to another dielectric medium. Then also certain changes will occur with this electric and magnetic field. So here also again I will be getting the dielectric to dielectric boundary, or dielectric dielectric boundary condition will be applied. Okay. Now you consider the case if this wall is made of some sort of conductor. Okay, so this may happen that this particular wall is basically made of conductor. Okay, so here this particular wall is basically made of conductor. Okay, now this wall is no more dielectric, so this is basically fully, what I can say, that is made of conducting material. Okay, so this is basically fully made of conducting material. If it is made of conducting material, then what kind of boundary I am going to get, or at the interface what kind of boundary condition I am going to apply. So initially the electric and magnetic field is traveling through air. Now it is encountering or it is going to face the conducting medium, right? A conducting wall is going to encounter. So here what kind of boundary condition I am going to get? I am going to get air to conductor. So dielectric to conductor boundary condition. So air is your dielectric and this is basically conductor. So in this particular case I am going to get, okay, so air to air to dielectric to conductor boundary condition. So dielectric to conductor. So dielectric to conductor. So this boundary condition I am going to get. Ideally, we have two different boundary conditions, as we have seen. One is dielectric to dielectric, another is dielectric to conductor boundary conditions. So these are fully different. In our next classes we'll see these conditions are fully different, and but this study is really required to understand the changes when the electric and magnetic field will pass through the different boundary or different interface consisting of different medium. So what kind of changes will occur, or what kind of changes will happen with the electric and magnetic field when it will pass through either conducting medium or some other dielectric medium. So that study is really required. Otherwise the propagation characteristics or many other characteristics cannot be explained nicely. So that is the reason these boundary conditions are quite vital to